Au nom de la société Eurochemic, je tiens avant tout à souligner l'éclat que donne à cette cérémonie la présence de Sa Majesté, le roi des Belges.
Your Majesty, Messieurs Ministers, the Eurochemic Company will put into operation the first plant to come into being through European cooperation.
May I give now a very short explanation on the technical part of the plant starter. Underwater, which provides shielding from radiation.
July 1966. During the inauguration ceremony of the Eurochemic plant at Mol, the King of the Belgians puts the irradiated fuel reprocessing plant into action. The inauguration marks the beginning of the operation period. The first reprocessing campaign for low-enriched, long-cooled fuels enabled final adjustments to be made to the plant. After decontamination and verification by the health and safety teams of the radioactivity level in the cells, specialized workers carry out the necessary modifications to ensure the satisfactory operation of all the installations. In each part of the plant, the equipment is now ready to carry out the requirements of reactor operators. Absolute filter sets, capable of retaining all traces of activity, allow 250,000 cubic meters of continuously controlled air to pass every hour before being released to the atmosphere. Here we see the dissolver, with its neutronic screen in specially treated wood. It is used for decanning and dissolving fuel elements. The pulsed columns for separating and extracting uranium and plutonium from the fission products, the evaporators, tanks, and piping. All the vital parts of the plant come together in these cells. Eurochemic is one of the joint undertakings of the European Nuclear Energy Agency of the OECD. It is the result of studies concerning the peaceful application of nuclear energy, and in particular, on the needs in Europe for chemical reprocessing of irradiated fuels from nuclear reactors. The plant can reprocess practically all types of fuel elements from research or power reactors existing or under construction in Europe. In this way, Eurochemic perfects reprocessing techniques and at the same time ensures the training of specialists in this field. Due to the high radiation level, all chemical operations are carried out in shielded cells by means of control valves in a gallery where the activity level permits permanent access. The operations are conducted from control panels where the majority of remote control apparatus is assembled. Samples of solutions are taken regularly during reprocessing. These samples are sent by a pneumatic post system to the analytical laboratory, where they are measured for radioactivity, acid, uranium, and plutonium concentrations, density, as well as other parameters. This information enables the operators and engineers to carry out each campaign according to the different characteristics of the fuels from different reactors.
50 grammes de plutonium, ce qui donne environ une perte actuelle de 4,5.
Each reprocessing campaign necessitates detailed and continuous coordination.
Yeah, and they are correct.
This coordination takes place during a discussion with the technical director and his engineers. Each one reports in turn on the latest events. Decisions are made, new instructions given, and others confirmed.
Mr. Ashley, have you anything to add?
We could not reproduce in our mock-up dissolver model. So we assume that the troubles arrive.
The irradiated fuels, most of which come from the company's member countries, are delivered to the Moll plant in transport casks and stored underwater while awaiting reprocessing. The geometry of the elements is quite varied. Some have metallic ends, which preferably should be cut off before reprocessing. This cutting is carried out underwater in the mechanical treatment pond. A carriage, controlled from a panel mounted on the side of the pond, serves to maintain the fuel element in position and to place it under the blade of the saw. The elements are then sent to the dissolver. This transfer is made by a charging machine of more than 40 tons. The length of some elements, sometimes more than 4 meters, the necessity for radio protection, and automatic remote control explain the size and weight of the machine. According to its original enrichment, the irradiated element is directed to one of the 3 dissolvers. Several elements may be temporarily stored in a shielded cell, where the loading into the dissolver takes place. The fuel element is transferred from the storage basket to the dissolver basket. The closing of the cover of this apparatus marks the beginning of the chemical reprocessing, which consists mainly of decladding and dissolving, of the 2 extraction cycles. And of the final purification of uranium and plutonium. For dissolving the can, different reagents are used for the various metals employed for cladding. Uranium is always dissolved in nitric acid. The different dissolutions generally take place between 70 and 120 degrees centigrade. It is in the pulsed columns that the solution containing uranium, plutonium, and fission products is put in contact with TBP, tributyl phosphate, during the 2 extraction cycles. At the outlets of the columns, the fission products, uranium and plutonium, are collected separately. The fission products are stored after concentration in a separate building. While awaiting the industrial application of research being carried out in the laboratories on the solidification of liquid wastes, they are temporarily stored in refrigerated tanks. The uranyl nitrate solution obtained at the outlet of the 2nd extraction cycle is concentrated in an evaporator. The uranyl nitrate, finally obtained, is transferred into special containers which are used for the transport of the solution. During this operation, samples are taken to control the quality and quantity of the final product. For the final purification of the plutonium, 2 sets of mixer settlers are used. At the outlet, the aqueous phase plutonium is precipitated in the form of oxalate by means of oxalic acid. The oxalate is changed into plutonium oxide by calcination, the final form in which the reprocessing plant delivers this product. The plutonium oxide is transported in containers called bird cages, specially designed to avoid any criticality accident. On leaving the plant, these final products are reintegrated into the fuel cycle. The plutonium oxide can be used either to make plutonium-enriched fuel elements or directly in fast breeder reactors. The uranyl nitrate is usually transformed into hexafluoride before being re-enriched in an isotopic separation plant. Eurochemic thus adds a link in the chain of the nuclear fuel cycle in Europe. The daily production rate can reach 500 kilograms uranium and 4 kilograms plutonium according to the type of fuel processed. In this way, Eurochemic is proving the quality of nuclear engineering reached in Europe in the reprocessing field. The increasing number of contracts with reactor operators, as and when power reactors in the member countries become operational, and the cooperation developed by Eurochemic with the rest of the European nuclear industry augur well for its future.